So, vector concepts. First off, what do we mean by a vector? Okay, and the easiest way to think about vectors is to think about them in comparison to what we call scalars. Scalars are quantities that only have a magnitude to them. So they only are represented by a single number. So that might be something like speed. Okay? When we're talking about speed, we can say speed is 10 kilometers per hour. Okay? Basically, we're only interested in the magnitude, that 10 there. If we're thinking about a vector, it has to have both a magnitude and a direction. So the corresponding vector quantity to speed is what we call velocity. A velocity might be something like 10 kilometers per hour, and we also have to specify a direction. So we'll put the direction into square brackets. So that would be 10 kilometers per hour west. Okay. Something else that might be a vector here, something like force is always a vector. Okay. We can have a force of 10 newtons, but we also have to specify which direction this force is acting in. So is it acting up? Is it acting down, to the left, to the right? And we can just say it's acting in the downward direction. Another example of a scalar here, something like energy. We might have energy of 5 kilojoules. Okay? There's no direction that this energy is going in yet. If we were talking about a change in energy, then we could start talking about which direction it's moving. But if we're just talking about the amount of energy, we're only interested in the magnitude, so it's a scalar quantity. So what do vectors look like when we're representing them? There's a bunch of different ways that we're going to use to represent vectors. One of them is what we've just done there with words and numbers. So something like 10 meters forward. Okay? Once I add that direction on there, that becomes a vector quantity. And we also have a bunch of symbols that we're going to use. So if we see something like this V here with a little arrow over the top, that indicates that that is a vector quantity. These two absolute value things around our vector telling us we're talking about the absolute value of that vector, or we're just talking about the magnitude of that vector V. Okay? So the magnitude of that vector, if we're only interested in the magnitude, we've turned that vector into a scalar by taking the absolute value of it. And you'll also see this notation here, AB with an arrow sign above it. Of course, the arrow indicates that this is a vector. So this is the vector from A to B. Where A and B are probably points labeled on some diagram or something like that. So we can use you can use words and numbers, symbols. We can also represent them graphically using arrows. And we're going to work a lot with that here in Unit 1. The length of this arrow represents the magnitude of the vector, and the orientation of the vector, of the arrow, tells us the direction of the vector. So if we've got a vector that looks like this, it has a length of 50 meters long. This might represent something like a displacement of 50 meters northeast, where we're using sort of the common sort of coordinate system like this. Okay, so that's basically what vectors are and how we represent them.